Welcome back to Semiconductor Spotlight, the podcast where we break down the silicon shaping our world. I'm Alex.
And I'm Sarah. Today, we're looking at a technology that is literally feeding the artificial intelligence boom. Whenever we hear about AI, the spotlight is, well, almost always on the GPUs, the massive processors from companies like NVIDIA.
Right.
But Alex, a processor is only as good as the data it can access, right?
Exactly, Sarah. And that brings us to the unsung hero of the AI revolution, high bandwidth memory, or HBM. To give some context, the global semiconductor industry is having a banner year in 2024.
Wow.
It is projected to push well past $600 billion in revenue with double-digit growth. A huge chunk of that momentum is tied directly to HBM.
So, what exactly is HBM? Let's translate this from engineering speak. If you look inside a traditional computer, the memory chips are laid out flat next to each other on a green board.
Mm-hmm.
You can think of it like a sprawling single-story suburb.
Right. And to get the data from that suburban memory to the central processor, the data has to travel down a relatively narrow road. For regular tasks, that's fine. But AI is different. Training an AI model requires ingesting billions of data points simultaneously.
Yeah.
Suddenly, that narrow road turns into a massive traffic jam. The processor ends up just sitting there idle, waiting for the data to arrive. In the industry, we call this the memory wall.
And HBM breaks right through that wall. Instead of building out like a suburb, HBM builds up. It uses a 3D architecture.
Okay.
Manufacturers stack memory chips on top of each other. They go up to 16 layers high, like a digital skyscraper.
The engineering required to make that work is mind-blowing. To connect the floors of this skyscraper, they use something called TSVs, through silicon vias. Wow! These are microscopic vertical wires. They are thinner than a human hair, acting like high-speed elevators, letting data zip up and down the stack instantly.
And it doesn't stop there. They place this memory skyscraper right next to the processor on a special foundation called a silicon interposer.
Hmm.
This allows them to build a massive data superhighway. We're talking thousands of lanes. The data transfer speed jumps from gigabytes per second to literally terabytes per second.
Which is exactly what those power-hungry AI chips need. Now, what makes this even more exciting is the corporate battle happening behind the scenes.
Right.
This technology is incredibly hard to manufacture. It has triggered a heavyweight boxing match between two South Korean tech giants, SK Hynix and Samsung.
Let's talk about SK Hynix first, because they really won the early rounds of this fight. They recognized the potential of HBM years ago and perfected their manufacturing.
Yeah.
As a result, they became the primary supplier for NVIDIA's most powerful AI chips.
It was a brilliant move. Their current generation, HBM3E, is in such high demand that their entire production capacity for 2024 is completely sold out.
Wow.
It's driving record profits for them. But as we know, you never count Samsung out. They are historically the undisputed king of memory, and they are not used to being in second place.
Exactly. Samsung is launching a massive counteroffensive. They've shifted their entire strategy, slashing their HBM development cycle from 2 years down to just 1.
Mm-hmm.
And they are aggressively pushing the next generation, HBM4.
This is where Samsung's unique corporate structure gives them a potential edge. Most companies only design chips, or they only manufacture them. Samsung does both.
Right.
For HBM4, they are using their ultra-advanced 4-nanometer logic process to build the base layer of the memory stack.
To translate that, they are essentially putting a highly intelligent foundation at the bottom of the memory skyscraper.
Yeah.
This helps manage power and heat, which is crucial because HBM4 doubles the interface width. Samsung just announced they've started mass production of this HBM4. It is hitting data transfer speeds of 11.7 gigabits per second per pin.
It's a staggering technical achievement. They are essentially saying to the market, we might have been slightly late to the HBM3 party, but we are going to own HBM4.
Wow.
They expect their HBM sales to more than triple by 2026.
It really is a fascinating race. SK Hynix has the current market dominance and deep ties with NVIDIA, while Samsung is flexing its massive manufacturing muscle to leapfrog ahead.
Exactly.
And ultimately, we all win. This fierce competition is what's going to make the next generation of AI possible. That's a great point, Sarah. The pace of innovation right now is just relentless. So, as we wrap up today's deep dive, here's a question we'd like you to think about.
Hmm.
As memory technology becomes just as complex and critical as the processors themselves, how will this shift the balance of power? Consider the world's biggest tech companies for the next decade. It's a great question to ponder. Thank you all for listening to Semiconductor Spotlight. We'll catch you in the next episode.